Hey guys, good morning to all. Welcome to the flight dynamics course. Today we're going to see the topic on weathercocking effect, which is purely depends upon the directional stability of the airplane. The weathercocking effect describes an aircraft's tendency to align itself with the relative wind direction, named after a weather vane or weathercock, which always pointed into the wind direction. This effect is crucial for directional stability, helping the aircraft to maintain a straight flight path. The vertical stabilizer is a primary component uh, respons- responsible for the weathercocking stability. Understanding these effects is essential for a designer for stable and maneuverable aircraft design. The main principle of this weathercocking stability or static direction stability keeps the aircraft aligned with the flight path. A positive yawing moment occurs when the aircraft experiences side slip, bringing it back to its alignment. This effect is driven by the aerodynamic force on the vertical stabilizer during a side slip. Weathercock stability is enhanced by increasing the surface area of the vertical stabilizer. This natural alignment is crucial for safe and predictable and handling in various varying wind conditions. The role of vertical stabilizer in weathercocking. Vertical stabilizer of a fin generated a restoring moment to align the aircraft with the relative wind direction. Its effectiveness depends upon the size, shape, and distance from the center of gravity. A larger stabilizer provides a stronger weathercocking effect, which improves directional stability. Placements further aft from the CG increases leverage, enhancing stability and alignments. Engineer balance stabilizer size to ensure sufficient stability without excessive drag produced in the vertical stabilizer. Coming to yawing moment and side slip, yawing moment is a rotational force around the aircraft vertical axis due to side slip. Side slip angle is the angle between aircraft forward motion and its symmetric plane. A positive yawing moment coefficient Cn with side slip indicates positive weathercracking stability. When the side slip angle increases, the yawing moment should counterattack the yawing and the restoring alignment. This characteristics ensures the aircraft naturally returns to its straight flight after a disturbance. The factor that affecting weathercracking effect, one is aircraft size, aircraft shape, especially fuselage and tail configuration, impact of weathercracking stability. A longer fuselage with a well placed vertical stabilizer generally enhance this effect. Wing sweep influences the weathercocking effect by shifting this distribution during side slip. Tail design and effectiveness are influenced by the aerodynamic interaction between fuselage and wing. Engineers consider this factor to create balance, stability, and control across the flight operation. Weathercocking effect and the crosswind condition. Weathercocking helps align the aircraft with crosswind, especially during takeoff and landing. Strong crosswind can exaggerate this effect, require pilot correction to maintain heading. Insufficient weathercocking stability may lead to challenge in maintaining runway alignment. Adequate weathercocking effect provides resistance to crosswind deviation during ground operation. Pilot must manage rudder input to counterattack strong weathercocking in high crosswind. So weathercocking stability and the pilot control reduces the need of constant rudder adjustment, enhancing control stability. Pilot relied on this effect for smooth, coordinate flight without excessive correction action. During turn, weathercock stability aid is maintained direction alignment. A balance between stability and the responsiveness allows pilot to retain control authority. Strong weathercocking is beneficial for stability, but excessive force may hinder maneuvering. Weathercocking effect in high speed and low speed flight. At high speed, weathercocking stability is more pronounced due to increasing aerodynamic force. At low speed flight, especially during landing, require greater pilot input to manage the alignment. Understanding speed influence on weathercocking stability is essential for safe handling in different places of flight. Design consideration. Coming to the design consideration, size and position of the vertical stabilizer is more important in the weathercocking stable design. The rudder size and fin area affected the direction stability. Tail configurations such as T-tail or conventional are influencing the efficiency of the stabilizer forces. Structural reinforcement ensures the stability component withstand aerodynamic loads at high speed. In conclusion, the weathercocking effect is essential for maintaining stability and coordinate flight. It enhances flight safe by allowing the aircraft to turn naturally to its flight path by yaw disturbance. Proper design of vertical stabilizer and control surface, optimizing the stability effect. Understanding weathercocking helps pilot and engineer to manage direction stability in all flight phase. Thank you guys. We'll see you in the next class.